make it wider to display the number properly. Once again, we start with line 1. Line 1 is asking the question, is x greater than 0? The answer is true. 10 is obviously greater than 0. We go to line 2. Line 2 puts a 0 into y, and we are done. Any questions about the first homework assignment, the multi-branch conditional statement assignment? No questions? Very good. Okay. So let's go ahead and at least close one window. And then we'll continue with our ungraded assignment about the pre and post stuff. So we'll go ahead and get started with this one. Now with this class, we are a little bit behind the other classes simply because we are a Friday-only class, and Friday-only classes, will suffer quite a bit because we have a lot of holidays that will impact Friday classes. My Tuesday, Thursday class are the safest from the holidays because I think only Thanksgiving takes one day away from Tuesday, Thursday classes, and that was it. And it's only one half of a week with that class because that class meets twice a week. With this class, there are many holidays that will land on a Friday, which means, and each time we miss one class, we miss an entire week's worth of stuff. Okay, so that's why, I have to kind of keep an eye on the progress of this class more so than my other class sections. Okay, so here is my, exercise. Okay, derive the post condition of line 24. Do this step by step with the rationale explained like what we have done so far in the class. The precondition of line 23 is blah, 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 and the code fragment is as follows. Okay, so with an assignment like this, okay, I'm just switching back to Moodle here, the non-assignment part. I can always open it as a tab, so I keep track of that in a tab. And what I would do is kind of go back here and look at the files that I have captured. If I were to do the homework assignment, I would do that. So I would click on the captured notes from last week and take a look at the text version, the text file, which is a plain text file. The funny part is if you open it using Notepad, you will see one long line, and that's it. So what you need to do is to use WordPad. Okay, use WordPad to open it instead of Notepad. Okay, any questions? If you have problem opening it in Notepad, one other thing you can do is to use Word. Microsoft Word can open it just fine. Okay, it's overkill, but it will get it done. Okay, so this one kind of demonstrates, the steps that are necessary. So we will just have to basically follow these steps. We can do this trick if and only if the following happens. So we'll follow these tricks and follow these steps to see whether we can apply the substitution method. So back to our homework assignment. Now the way you do the homework assignment like this is you just basically type in the text editor that is below the question. But since I'm not logging in as a student at this point, I cannot do that. I will just go ahead and let me see what would be a good way to do it. Oh, okay. This is how I would do it. Instead of saving my files as a separate text document every single time, I'm going to use a feature in Moodle. In Moodle, I can add a resource anytime I want to. And in this case, I can compose a web page, which means I am actually composing a web page on the fly as the notes for today. So notes of 2010, September 17th. And this window now becomes my note taker. Okay. So now that I have my little note taker window, I can go back and take a look at the question itself, just like that, and start to do my homework. Okay, the precondition of line 23 is x is greater than z and y is less than 2. We don't ask why that is the case. It is just given to us as something that will always be true by the time we get to line 23. So that's fine. The question now is, what is post 23? Well, according to those steps, step 1 says, does the right-hand side of line 23 refer to the left-hand side? Does x plus 1 refer to x?
Yes.
Yes, okay, very good. So in your comment, when you do a homework like this or in the exam, you have to explain it. You have to say the right-hand side of line 23 refers to the left-hand side. Okay? You're basically explaining your rationale of why you are doing the derivation the way that you do it. Step 2. The question is, do we have a way to undo what the right-hand side is doing? Is there a way to undo adding 1 to something? Yeah, we can take away. Very good. So there is an inverse function. So in other words, if the right-hand side is f of x equals x plus 1, then f prime of x, which is the inverse function, is going to be x minus 1. So we know the inverse does exist. Now you can also do it one step further and prove to me that it does work. In other words, you can say f prime applied to f applied to x is basically f of x minus 1, which becomes x plus 1 minus 1, and if you work this out, the math does return an x. So this is a step of verification to prove to me that the inverse function is in fact the inverse function of the right-hand side. Okay, so step 3 is to use the substitution method. Use the substitution mechanism, and that simply means that post 23 in general is the result of substitution applied to pre 23. What we are doing is we are trying to locate all occurrences of the variable on the left-hand side of line 23. So in this case, the variable on the left-hand side of line 23 is x, and we want to replace all occurrences of x by f prime, the inverse function, applied to x, like that. Any questions at this point? This part is a template, okay? Once we know the right-hand side refers to the left-hand side, once we know the right-hand side has an inverse function, this is what we do just blindly. It is just mechanical. Have we gone through what is the substitution operation? No? Okay. Well, so that means that I can explain that along with explaining the answer to this question. The substitution operation, this notation here is nothing more than saying we're going to replace something in pre-23. We're trying to find all occurrences of x and replace each occurrence with f prime applied to x. That's all it is saying. Is that okay with the meaning of the substitution operation? Okay. Yep.
The substitution operation, maybe I'm missing something here. Seems to me that if x is going to be substituted by function x, which is x plus 1, then I don't understand why on bottom line when we're substituting the precondition of x, we're substituting it with f prime.
We have to use f prime because we are trying to reverse. Remember, at this point when I'm stating post 23,
right,
the value of x is post operation. It is post assignment on line 23.
Okay.
So I would have added 1 to x already at this point. However, pre-23 is stating how x relates to the other variables or constants prior to the execution of line 23. So in order for me to keep all of those relationships, I have to say, oh, but x is now 1 more than what it was. So I have to undo that and say, okay, let's think about x minus 1 because x currently is 1 more than what it was. So if I use x minus 1, it is specifying the same value that x had before line 23. And every relationship that I knew about x and the other constants and variables would still hold as long as I refer to it as x minus 1 instead of x. In other words, the f prime is basically undo. It is undoing what line 23 has just done to x so that I can revert it back to the old value, which is still fine. I can still use the old value of x to state how it relates to everything else. Yep.
Is that simply saying that if you undid what you did at line 23, pre-23 is still true? Is that what you're saying?
It is saying that if I undo whatever line 23
If you undo
did,
whatever you just did, then this still holds true.
exactly. It's, I gave an example to my other class, which I think is actually pretty funny, but it's still true. Okay, so we'll just say that the statement, so it has nothing to do with algorithms, but you can actually see how it relates to algorithms. So the statement goes like this: Bill Gates is more wealthy than tech. Okay, so that's a precondition. Bill Gates is more wealthy than tech. That's all there is to it. I didn't say how much more wealthy, but I'm just saying that Bill Gates is more wealthy than me, maybe just by $1. Okay, maybe, but I didn't tell you. Okay, so the next statement that I tell you is Bill Gates went into 7-Eleven and spent $1 on something, beef jerky, whatever. Okay, so the post condition is going to be what? Do we know for sure that Bill Gates is still more wealthy than me? No, because he might be just 50 cents wealthier than I am. So once he spent that $1 to buy beef jerky, he would not be more wealthy than I am, right? But what I can say is, Bill Gates' worth after spending the $1 on beef jerky plus 1 would still be more than my wealth. I can say that because I know that he was wealthier than I was before he spent that $1. So if I say with his current wealth, after spending that $1 on beef jerky, if I just give him that $1 back, he will still be wealthier than I am. And this is exactly doing the same thing, but in much more, kind of in a formal way. Are you guys getting the idea of why we use the inverse function? Okay. Now the inverse function, one thing you have to remember is the inverse function does not actually undo what we did to x. It is simply reverting back to the value that x had, but we are not changing the value of x at this point. Okay, that's it. That's important. So once we understand the substitution operation, which is really just a notation kind of thing, we can go ahead and expand it. The first thing I would do is to expand pre-23. Pre-23 is over here. I just do a copy and paste. That's really easy. And we keep x, and then x prime of x is x minus 1, so I would copy and paste it here. Now typically what I would do is I would put parentheses around it, so that in the substitution, when I do the substitution, whenever I see an x, I will replace it with x minus 1 in parentheses. The nice thing about these extra parentheses is they actually worked out really good because they, even if I used x in a multiplication, using the parentheses surrounding x minus 1 means that even if x was multiplied by 2 before, it will still be very clear that we are multiplying 2 to the entire difference of x minus 1 and not to x minus 1. So that's basically the result of post 23. Yep. Mm-hmm.
Can't we say like that x will be equals x minus 1?
No, you cannot say that. Okay, he was basically asking, can we say and x equals x minus 1? The answer is no, we cannot say that. Because you cannot find any number that it would equal to itself minus 1. So we definitely don't want this component here. This is what you do when you use the other rule. When you use this forget operation, then you can add this part. So in this case, we definitely do not want this part here. Let me see if I can emphasize the fact that we don't want that part. Strike out. Okay, are we all clear that we do not want to add x equals x minus 1 at this point? Okay. Yes?
Could you just say x is greater than z because you're minus it? Even if you didn't have that minus 1, it would still be greater than z.
But we want to be as specific as possible. X minus 1 is greater than z, or x is greater than z plus 1 is more specific.